Alright guys, so up next we are going to look at finding roots of equation using Newton-Raphson's method. So this method is actually nice, it's okay, you can use your calculator as well, but I'm just going to show you or teach you a few acts and walk through. So first off, we are given this is our f of x and we are not giving our roots. So the first thing I would do on a normal day is okay, input this into your calculator, start trying 1, 2, 3 and whatnot, but as a smart guy you can always put this in your calculator and it's going to tell you directly what the number that will give you zero is, and you just mess around. If it gives you, let's say it gives you 2.5 as the number that will give you 0.09, you're just going to mess around and use 2.2 and use 2.52, something like that. So you fall in between because your goal, remember, is to always get -1 and positive number. You get when you input one number and the other you want to get. So for this now, there's something tricky about this question, right? So for this equation, yeah, another thing, you need to get your A game up because you'll be differentiating a lot when it comes to this side of this method. So the first thing you need to pay attention to, the input 2 here, the input 2.5 here, it gave us -1 and -5. So I'm going to draw a number line now. Oh, I can't even use my pen. Then it's okay. I was going to try draw a number line, but I can't do that. So how do I do this? How do I do this? I'm trying to explain something. So for this now, right? Some of you might be like, okay, let's do 2 plus 2.5 divided by 2. Then whatever number it gives you, it falls in the center. That is actually wrong. You're going to spend too many time counting and counting and counting because there is no way the half, like how would I say this? Okay, let's just do math. This is -1, right? So next after -1 is 0. We now have 1, we now have 2, 3, 4, 5. You feel me? So now if it was something that it was -1 and 1, I would have said you should do the average 2 plus 2.5, but no, 5 is very very far away from 0, but -1 is closer. So if I were you, I will choose a number that is close to 2, but you can always use a calculator. I think calculator will tell you maybe it's 2.1, like the exact figures or something. So now this is why I say you fall victim. Let's just jump here. As you can see here, 2.1, right, is giving us 0.01. So if we are done what I said earlier, doing divided by 2, addition of these 2 plus this, 2 plus 2.5 divided by 2, I think you get 225. And can you see 225 is way too far from 2.1? You're still going to be getting things like probably positive these far away from 0, so it's going to waste your time. You just need to pay attention to your number. This is -1, this is 5. So our w is closer to 0. You feel me? So this guy is closer to 0. You're going to choose a number that is closer to 2 to get your center number. So let's work on. So now you need to differentiate. You know how to differentiate. 3 times this, then 3 minus 1, it falls to 2. Then this cancels the hex, it becomes 2. Then you input your figures, which is 2 and 2.5. So this is the main formula you need to cram. This formula, you need to cram it to find your A1 is our future here. We are looking for the future, the next A. Then this is the present A that we know, and this is like the normal equation and differential equation, right? So as you can see, the present A we know is 2, right? This 2, we know this 2. So when we input 2 into the equation, that's our f of A -1. So we're going to have -1 here, then differential version of it. So where do we do differential here? So differential here, we input 2 here, we got 10, so over 10, right? Is that making sense? Yeah, so 2.1. Okay, so as I was saying, since we got 2.1, cool, we are not supposed to use 2.1 in our next line. Now let's ask ourselves, why did these people use 2? Right? Why did they not use 3, or sorry, why did they not use 2.25? They used 2 instead because the figure 2 was closer to 1. We would have fallen victim saying 2 plus 2.5, like I said earlier. So they used 2, and 2 kind of guided them to 2.5, 2.1. So using 2.1 now is kind of guide them to get their 0. Yeah, so getting their 0, they input everything, they look for the differential version when f of x is equals to 2.1. So they got this, then they did the equation, inputting equation and differential equation, inputting that answer. You get what I'm saying, Sha? So see the answer here. This is the normal equation 0.06, and this is differential equation 11.23. So they put it here. So they did the whole subtraction thingy and they got 2.5. So you're going to use this again. This is our future A that we are looking for. This A3. You're going to use A3 again. Look for input A3 into the normal equation, then input A3 into the differential equation. That's this answer. So as you can see, we did the same thing and we got this number 11. So we now apply the normal formula, this formula right here, saying A3 is equals to this. Okay, that was it. So cool. But the main thing is you should know the pattern. And I want you to study something. As you can see from here, the answers are already looking alike. So because we got these two answers to be the same, that's why you kind of put a stop. Like, come on, look at now. These guys are looking alike. So if I keep going, I'm just gonna be doing the same thing, the same thing. But look at this first guy now. Where's the first guy? Why is he hiding? Why is this first guy hiding? Okay, Sha, now. But this is Isha. We use these two first guys, these two guys, and we got this. But where is that of two? I'm looking for that of two when we used to. Where did we use to? Where did we use to? Where did we use to? Okay, yeah, look at two. Two here gave us 2.1, right? You can see that 2.1 is different from this because that guy is far away from zero. Just know that all we are trying to do is we are trying to look for center of balance. So look at, since you got something looking alike, just stop and tell them, bro, A3 is equals to A2, and move on to the next question. Bye and peace out. So okay, this looks simple actually. It's just differentiation. You three times this, that's nine, yada yada, then you put your x. I'm looking for a specific question that looks tactical. Okay, this one also looks simple. Our f of x here is simple. Just know this formula. It is original over differential, then your a minus that. So yeah. Okay, this is also easy to differentiate. Which one again? Yeah, something like this. There are two things happening here. Yeah, let's read this. So for this one now, two things are happening. We have exponential of this to differentiate this. Some of us will just sit in the dark and be like, wait, what? Except we know it already. So for the first thing you need to do is you need to bring this guy over the bracket, right? Every equation you must always equate it equals to zero. So if you see the pattern, all the question we've been treating, where's this? Okay, can you see it's equal to zero? But here now they are trying to confuse us that e exponential x is equals to 3x. So you're supposed to bring to the front. Can you see? A plus is here, so the brought it front and equal to 0. Yeah. Then this is also x log. So this x log, I think you need to use product rule here. And okay, let me just explain it real quick. So for this x log, on the normal the log x is going to be 1 over x log, no, L 1 over x ln a, right? Or our a here is going to be the 10, open bracket 10. So 1 over x ln open bracket 10. Then to differentiate this x is gonna become, let's just go through chat. But you need to use product rule, udv. I don't use udv vdu. What I do is I do u prime v, then v prime u. That's why I use for my own differential equation when it comes to product. What else is happening here? So this one might look very tactical, like, oh, they are jumping steps, so they differentiated here. And yeah, the inputs, this is not my equation, the input three here, but I think when you differentiate, that's when you get this. But remember, I just said the answer. So this is going to be, when you differentiate this, it's going to be x over x ln open bracket 10. So the x will cancel the x, it's now be 1 over ln 10, right? Where is my calculator? Let me check. 1 over ln 10, 1 over ln 10, sorry, close the brackets. Exactly, 1 over ln 10 is 0.4342. So yeah, can you see 0.4342? That's 1 over ln x for the differential. Then you input everything you need to input. I remember that it is u dv v du. Yeah, so that's why it's expanded. So but this is one part, one half of it that became, that's 1 over ln 10 that became 0.44343 here. So yeah, this one also, can you see they kind of confused us here also, but just know that x equals to this means initially x was raised to power 3 equals to 18, right? Where is it exactly? See, it means x was raised to power 3 equal to our n, right? So it was because, they had to cancel out the cube here. That's why it became cube root on the other side. So that's raised to power 3. What else again? I think that's all for now. Then let me stop.